Hi and hello students. Today we are going to start the very important chapter that is called circle. Okay, see, this is a circle. You have seen it in standard 7, in standard 8 and in standard 9. We know all the properties of circles. So I am going to start it from the basic concepts. So which is the first property of the circle? Yes, you know it well. See this? These are the two arrows. Have you seen this? Okay, what they are? Yes, absolutely correct. Your answer is right. These are the radii of the same circle. So this is a very important property of this chapter. आप लोग तो बोलेंगे सर इतना सारा सिंपल प्रॉपर्टी है क्या याद रखना है बट रिमेंबर दैट दिस इज अ VIMD प्रॉपर्टी ऑफ दिस चैप्टर रेडियाई ऑफ सेम सर्कल आर इक्वल सी दीज आर द टू रेडियस दिस इज द वन एंड दिस इज द अनदर वन ओके सो इफ यू फाइंड द डिस्टेंस एनीवेयर दिस इज इक्वल सो देयरफॉर you have to remember the VIMD property of this chapter. Radii of same circle are equal. So here it is a board and here I have drawn a one property that OA is a radius and OB is also radius. So we can write it OA equals to OB and because radii of same circle. Okay, so what are the uses of this property that you have to also remember? ये property का use क्या हो सकता है हम कहाँ use कर सकते हैं? So there are two uses. One, if you want to show the triangles are congruent, then use this property first. Ask the circle, is that radii of same circle are there? Remember once again, if you want to show that the triangles are congruent in a circle, then ask this property. Okay, second use, if I join the end point of the radius, then what do you get? These are the radii of same circle, therefore these base angles are congruent. So it is converted into isosceles triangle. So if the sides are congruent, then base angles are congruent. It means it is useful to find out the angle also. So remember, this is the VIMD property of this chapter. Okay, now I am going to show you the another property. See this one. Here is this is the tangent of a circle. Okay, so this is called a tangent. What do you mean by tangent? Tangent is a segment that intersect the circle at a single point. This is a single point. So this is called a tangent. Now I am going to show you the very again important property. See, this is the radius and this is the tangent. If I move it, then what will happen? See, this is the radius and this is the tangent. Always remember that it makes a 90 angle here. Can you see this? It is on 180, it means it is on 90. So tangent is always perpendicular to radius. That you have to remember. Okay, इसके लिए मैं एक आपको simple idea बताता हूँ. Tangent and radius are the two sisters. Tangent and radius are two sisters. They have a one brother. वो कभी भी बीच में आता है लेकिन उनके साथ ही रहता है and that is called a 90 angle. This is the 90. ये उनका भाई है. So this is the radius and this is the tangent and therefore we can say that tangent is always perpendicular to radius. Tangent is perpendicular to radius. So it makes a 90 angle. दो बहने एक भाई. Always they are with each other. अगर ये दोनों है तो 90 100% है. अगर रेडियस और 90 है तो tangent 100% है. Okay, that you have to remember. This is again the second important property of this chapter. If you see the radius and tangent, 100% it makes a 90 angle. Therefore, it is called a tangent is perpendicular to radius. Okay, now I am going to teach you the third property. Okay, now see and observe this one. See what you observe. These are the two tangent segments. See, this is also a tangent and this is also a tangent. These are the two tangents. What do you observe? They are equal. So, we can say that tangent segments are equal. We know that this is the outside point of the circle. So, from outside point, if you draw the tangents, these tangents are congruent, and therefore we can say that tangent segments are congruent. So here I am going to write it PA equals to PB, and reason for this one, tangent segment are equal. Either you can say that they are congruent. With this I am going to tell you the one another thing. Okay, these two are the tangents. Okay, if I draw the radius here and radius here, then what will happen? What will happen? Let me tell you here. See this? These are the two tangent segments. Okay, and these are the two radius. Okay, now observe this. The tangent and the radius makes a 90 angle. Here it makes a 90 angle and here it makes a 90 angle. So it is the 90. Here it is the 90 angle. Here it is the 90 angle. So can you tell me what about these two? Yes, very good. इनका अगर addition करेंगे तो you will get it 180. So this addition is also 180. We know the property. Which is the property? The sum of all the angles of a quadrilateral is 360. Okay, the sum of all the angles of a quadrilateral is 360. That you have to also remember. Tangent and radius makes a 90 angle. Tangent and radius makes a 90 angle. So therefore, the remaining two also 180. So the sum of all angles of a quadrilateral is 360. So you have to remember these four properties of the first part of this chapter. Let's start the sums which depends upon the properties. Okay, the sum number 1. Here it is given one circle whose center is C, and there is a line AB which is a tangent. Now what you have to find out, and what is given? The radius of the circle is given 6 cm. Then you have to find out angle CAB. So here it is a CAB. So can you tell me the measure of this angle? Yes, I know that you know the properties well. Angle CAB equals to 90. Why? Because this is the radius and this is the tangent. We know that tangent is always perpendicular to radius. So I have written the shortcuts. I use always the shortcut, but don't use the shortcuts. You have to write it in full form. Tangent is perpendicular to radius. Therefore, this angle is 90 degree. So let's find out the second one. Distance of the point C from the line AB. क्या रहेगा? Yes. This is 90. Angle CAB equals to 90. So this is perpendicular to the line. Yes. And what is this CA? CA is nothing but a radius. And radius is already given 6. So what is the distance of the point C from the line AB? Yes, it is 6. So we have to write distance of point C from line AB equals to 6 centimeter, because CA is a radius. You have to write it like this. Then we are going to start the third. If AB is 6, this is already 6 centimeter and AB is also 6 centimeter. Then find the BC. You have to find out. And you know it well. Which triangle is there? Yes. This is a right angle triangle. And you know it well. In right angle triangle आएगा तो कौन आएगा? Who will become? Exactly. Pythagoras will be there. So here we have to write it in triangle CAB. Major angle CAB equals to 90. Therefore, by Pythagoras theorem, I have written the shortcut abhi, but don't write the shortcuts. Here you have to write the Pythagoras theorem. Opposite to 90 is called a hypotenuse. So BC square equal to AC square plus AB square. Side 1 square plus side 2 square. So this is 6 square plus 6 square. 6 square is 36. This is 36. So if you add it, it will be 72. And then if you take the square root of this one, it will be root 72. And we can factorize the root 72 as a 36 into 2. So what is the root of 36? Is a 6. So our answer is 6 root 2 centimeter. So the distance AB, either length of AB is 6 root 2 centimeter. Then the question number 4. Question number 4. We have to find angle ABC. So you have to find out this angle ABC. How can we find out this angle? We know that this is a radius. It is given 6 centimeter. AB is also given 6 centimeter. It means this is an isosceles triangle. We know that if the isosceles triangle is there, then base angles are congruent. Therefore, these two angles are congruent. So how you have to write it here? AC equals to AB. It is given as a 6 centimeter. Therefore, we can write it angle ACB is congruent to angle ABC because of isosceles triangle. And then let angle ACB equal to angle ABC equals to X. And we know that the sum of all the angle of a triangle is 180. So in triangle ABC, angle ACB plus angle ABC plus angle BAC equals to 180. So ACB is X, ABC is also X, and we have to find out BAC. BAC is already given 90 equals to 180. So X plus X is a 2X. 90 goes on that side. So 180 minus 90. So 2X equals to 90. So 2 goes on that side. So 90 divided by 2. So you'll get it X equal to 45 degree. It means angle ABC equals to 45 degree. This is your answer. Let's start with the example number 2. Here the two things are given. The radius of the circle is given 5 centimeter and OR is given 10 centimeter. And you have to find out RM and RS first. Okay. We know the property. I told you that if the radius and the tangent comes together, these are the two sisters having a one brother. You are right. So it makes a 90 angle here. So something is here, it makes a 90 angle. So I am going to write it first. Angle OMR equals to equals to 90 degree. So what is the reason for this one? Yes, tangent is perpendicular to radius. So we know that if it is 90, it is 5 centimeter and then 10 centimeter. We can find out MR by Pythagoras theorem. It is very simple. So you have to write it in triangle OMR. Major angle OMR equals to 90. Therefore, by Pythagoras theorem, opposite to 90 is called a hypotenuse. So which is the hypotenuse? OR. So hypotenuse square equals to side 1 square plus side 2 square. So equals to OM square plus MR square. So OR is given 10 square. OM is given 5 square plus MR we have to find out it. Okay, so 10 square is 100, 5 square is 25 plus MR square. We have to find out the value of MR, so 25 will come on this side. So 100 minus 25 equal to MR square. So 100 minus 25 is 75. And then by taking square root, you can write it MR equal to root 75. This is because 75 is not a perfect square. So we can factorize it like a 25 multiplied by 3. Okay, and we know that 25 is a perfect square of 5. So our answer is 5 root 3 centimeter. So we can write it RM equals to RN radius tangent segments are equal. So I have given the result tangent segments are equal, but RM equal to RN, and therefore RM equals to RN equals to 5 root 3 centimeter. This is our first answer. We have to find out angle MRO. Here it is angle MRO. How can we find out this angle? This is 90 given, but this is not given. So we cannot use the angle property. So we can use the segment property. You have studied in 9th standard that opposite to 30 is half to hypotenuse. I am going to use it. OM is given 5 and then OR is equals to 10. If you divide these two segments, what will you get it? OM upon OR equals to 5 upon 10. So equals to 1 upon 2. It means OM upon OR equals to 1 upon 2. So OR goes on that side, you will get it OM equal to half OR. So by converse of 30, 60, 90 degree triangle theorem, what it says? It says that opposite to 30 is half to hypotenuse. 90 के आगे वाला hypotenuse होता है. So it means 5 is half to 10. So 5 के आगे वाला angle जो है that is called a 30 angle. Therefore angle MRO equals to 30 degree. Now the next one we have to find out MRN. How can we find out MRN? Very simple. You got it here 30. So it will be 30. But how? So for that you have to show that these two triangles are congruent. Then you will get the answer. Don't write it directly. If you write it directly, you will get the 0 marks. Okay. So I am going to explain you how to find out the value of this one. Here we have to write it. You have to show that these two triangles are congruent. We know that these are the tangent segments are equal. These are the radii of same circle are equal, and this is a common side. Therefore, these two triangles are congruent by S test. So here you have to write it in triangle OMR and triangle ONR. Segment OM is congruent to segment ON, radii of same circle. Okay, OM equal to ON. These are the radii of same circle. Then segment RM is congruent to segment RN. These are the tangent segments. Okay, and then we have to write the segment OR. Segment OR is congruent to segment OR. This is a common side, and therefore triangle OMR is congruent to triangle ONR because of S test. Okay, and therefore angle MRO is congruent to angle NRO. What you have to give? Give the result CACT, corresponding angle of congruent triangle. That you can write the shortcut. This is allowed for exam. But angle MRO equals to 30 degree. Therefore, angle NRO equals to 30 degree. Now we can add these two, so we'll get it MRN. Angle MRN equals to angle MRO plus angle NRO. So it is 30 plus 30. We get the angle MRN equals to 60 degree. Let's start with the third sum. Here we are going to start the sum number 3. Angle MON is given 110. You have to find out angle MRN. Which property you are going to use? Very simple. Radius है, tangent है, दोनों को याद ही रखना है. Radius and tangent साथ में दिखा तो what you have to write it? The back is 90 angle. This is 90. This is also 90. So we have to write it. Angle OMR equal to 90. Angle ONR equal to 90. So what is the reason for? Tangent is perpendicular to radius. And I told you that the sum of all the angle of a quadrilateral is 360. So you have to write it in quadrilateral OMRN. Angle MON plus angle OMR plus angle ONR plus angle MRN equal to 360. OMN is given 110. This is 90. This is also 90. And you have to find out MRN equal to 360. So if you add this, what do you get it? This is 180. Then 190, 290 plus angle MRN equal to 360. Now 290 will go on that side. MRN equal to 360 minus 290. So MRN equals to 70 degree. So this you get it here as a 70 degree. Let's start with the example number 4. Here you have to show something. What you have to show? That OR divides the angle MRN. What do you mean by divide? Yes, divides means it makes two congruent angles. It means you have to show that these angle and this angle are congruent. So I am going to write it here. You have to show that MRO is congruent to angle NRO. If you show that these two angles are congruent, then we can say that OR divides the MRN. But in 9th standard you have studied. How can we show that the two angles are congruent? Very simple. When two angles are congruent, if the two triangles are congruent, we can show that these two triangles are congruent easily. Tangent segments are congruent, radii of same circle, and this is a common side. So first you have to write it here. Prove in triangle OMR and triangle ONR, segment OM is congruent to segment ON. What do you have to write it? Radii of same circle. Then segment RM is congruent to segment RN. These are the tangent segments. And then you have to write segment OR is congruent to segment OR. This is a common side. I have written all the shortcuts, but remember, don't write the shortcuts. So you will get the three things. Therefore, triangle OMR is congruent to triangle ONR because of by S test. And if we know that if the triangles are congruent, angles will be congruent. Therefore, angle MRO is congruent to angle NRO. The reason for this one is CT corresponding angle of congruent triangle, and therefore we can say that segment OR divides the angle MRN. We have proved this.